Welcome to myself Vinay Bagal, Assistant Professor, Satyasai College of Pharmacy, Varnanagar. Today we will discuss about the chiral molecules. After completion of this presentation, learner must know to identify the chiral compound, the meaning of the superimposable, meaning of non-superimposable, and to identify whether the compound is the optically active or the inactive. So, what are the chiral molecules? Under the chiral molecules, but basically we have to discuss about the stereoisomers, and the second one is the optical isomers. Stereoisomers are the molecules with the same arrangement of atom but different orientation of group in the space. And the optical isomers are the mirror images of each other and that cannot be superimposed. So is the basic difference in between the stereoisomers and the second one is the optically isomers. So molecule must be asymmetric in order to exist as a pair of optical isomers, and asymmetric molecule is termed as a chiral. Typically, a carbon atom is a chiral center if it is bonded to four different groups. Then and then only we have to say that particular carbon is a chiral one. Clear? Observe this, an analogy of optical isomers. If two compounds are mirror images of each others that cannot be superimposed and that are called as the optical isomers. Okay, this one this one is a mirror image of a compound which is a superimposed. So the compound are mirror images of each other that cannot be superimposed, and these particular compounds are called as optical isomers. So here are the few we have to discuss about the few examples of the two chiral molecules. Okay, these black balls represent the carbon atoms. Carbon number 1, 2, 3, 4, 5, and 6. Okay, which is having a chain. Okay, here methyl group is present and here only H, only one hydrogen atom is present. So this is the optical isomers. Optical isomers. When we have to compare this one is a mirror image of each other. So the optical isomers of 3-methyl hexane. This is the second examples of a chiral center. Okay, at a carbon number 3, this particular carbon number 3 is a chiral center, and here at a carbon number 2, okay, is a chiral center. Okay, in previous slide we have to discuss about where the superimposed and non-superimposed. Then and then only it will be possess the chiral. Then second, what are the optically active compounds? The chiral compounds is optically active. Okay, all the chiral compound is optically active. That is, it rotates the plane of polarized light. Okay, that might be rotated at the left hand side or the right hand side. So a compound that rotates the plane of light clockwise is called as the dextrorotatory, while a compound that rotates the plane of light counterclockwise is called as a levorotatory. Okay, keep in mind this the basic difference in between the dextro as well as the levorotatory. Both are optically active, but the direction of the rotation is exactly opposite with each other. So the optical isomers have the identical physical properties, except that they rotate the plane of polarized light in opposite direction. So in their chemical properties, optical isomers differ only in a chiral, that is the asymmetric environment. So this one is the rotation of the plane polarized light by an optically active substances. Okay, so this is the source of a light. Second one is the unpolarized light oscillate in the plane. Third one is the first polarized filter. Then this one is the plane polarized light oscillates in only one plane. Then the rotated polarized light. So this is the angle of the rotation, and this one is the second polarizing filter, that is the analyzer, which measure the angle of rotation in degrees. Okay, if that particular compound is the optically active and the levo rotatory, then it will be rotate at clockwise, sorry, anti-clockwise direction, and if the dextrorotatory is a vice versa. So this is something about the optical active compounds. Thank you very much.